Bonjour. Bonjour et bienvenue à Beyond OWASP Top 10. No, sorry, I'm not gonna do this one in French. I apologize. I'm from Canada, so I do speak a little bit of French, but I won't embarrass myself by trying. So we'll do this one in English. However, this one's going to be a little bit quicker because I know that a lot of you are still trailing back from lunch because of the stringent Disney security. Security just always a pain, isn't it? It's kind of ironic. So welcome to this talk. It's called Beyond OWASP Top 10. And let's get into it as people stream in at the last minute. All right. So first up, this is me. My name is Hnatiw. I'm a senior security researcher at Security Compass. It's a company that does security testing of all sorts, and I'll be basing a lot of my work on my research and on the other work that our consultants and our other my coworkers do as well. So that's where I come from. My background is pretty diverse in IT. I was a software developer professionally. Now I just do it for hobby. I was a college professor in application security, security consultant, system administrator, web developer, all that stuff. Basically, I've seen a lot. One thing to note, my Twitter account is @inspector. It's pretty easy to remember. It's inspector with a 3 and an RE. Follow that because I'm going to be posting my slides and everything later on and a little bit more detailed write-up about this. So if you want some more information further on, be sure to check that out. I'll be giving my email address at the end, so if you want me to send you slides after, you can use that as well. So let's dive in. What is this talk about? This talk is about OWASP. But more specifically, as this laser pointer falls apart, more specifically, it's about their OWASP Top 10 project. So the OWASP Top 10 project is a project by OWASP, which is the Open Web Application Security Project, where they list out, or they try to list out, the top 10 security vulnerabilities in web applications. So it's kind of the de facto standard when it comes to web application security, and it's often what we give developers when they ask us, what do I do for security? What's the security thing when I'm developing web applications? Not only that, when we're doing penetration testing, when you're actually doing security assessments of web applications, typically it's used as a categorization scheme as well. So you say this particular vulnerability falls under the cross-site scripting, or it falls under security misconfiguration, which are different categories of the OWASP Top 10. However, unfortunately, actually I'm going to cover the next slide, which will talk about coverage as well. This is from the SANS 2015 State of Application Security report. Basically shows the top application security standards or models that organizations follow. And as you can see, the OWASP Top 10 is by far the most common one that organizations follow. This is great as a first step. However, the problem with this is that the OWASP Top 10 does not cover everything. It does not even come close to covering everything when it comes to web application security. So this talk is about those other vulnerabilities that aren't covered by the OWASP Top 10. So when you're looking at security vulnerabilities in web applications, you need to be aware that there is way more than that, and it's something that you have to continue to learn. So let's dive into the OWASP Top 10 first. So I will cover this briefly, but first one is injection. It's basically when you can pass in user-controlled data, or an attacker-controlled data gets passed to an interpreter as part of a command or query. So an example of this would be SQL injection. Second one, broken authentication session management. This is basically where any issue where there's like a session ID that can be guessed, or there's some way that it could be, you can grab the session ID through a cookie or whatnot. That's broken authentication and session management. There's more to it than that, but anything to do with authentication session management kind of falls under there. Cross-site scripting. Most people know about this, but it's where an attacker can inject their own code into a browser's session in the context of their client. So it's usually JavaScript. And insecure direct object reference. If you ever see a website where you can directly go to a file or go to a page based on a unique ID, if you can browse to it and there's no access controls provided on that, that's called an IDOR. Next is security misconfiguration. This one's kind of a bit of a catch-all, but if you're using a product that is not configured correctly, so for example, in the Java Springs framework, they have an option to enable CSRF protection. If you disable that explicitly, that would fall under this. So those are the first 5. Next one, sensitive data exposure. Basically, you're not encrypting stuff at rest or in transit. Next one, you're missing some kind of access control around functions. So before I talked about authentication and session management, but this one is if you're looking at a specific function in an application, so if you're calling, I don't know, /admin/delete user, that is a function. If you don't have the proper control around that individual function, then it will fall under this. Cross-site request forgery basically allows an attacker to, or an attacker can force a user to make a request from their browser, and if they're authenticated already, it will pass their session token in a cookie with their browser request. That's a cross-site request forgery. This one, using components with known vulnerabilities, basically just patch. So if you're using something that is not up to date and has security vulnerabilities that are known, falls under this. And last but not least, unvalidated redirects and forwards. And this basically is, an example of this would be an open redirect. So if you have the option to pass a URL that you can actually explicitly state what URL you're sending them to, an attacker can basically send someone wherever they want them to go. So that could be a malicious website, drive-by download, whatever. So those are the OWASP top 10. So that's just a basic overview of what's covered in there, which is a decent coverage, and it's a great place to start. So it's a great place if you don't know anything about security and you're a web developer and you need to know what are the basic concepts that I need to understand before building a web application. However, as I mentioned before, there really is a lot more than this because this is trying to cover the most common ones and not necessarily everything, and not necessarily the most damaging ones either if they occur and they're more rare. So let's get into the first one that falls outside of the OWASP top 10, and that is HTTP parameter pollution. Try saying that 10 times fast. It has a CWE as well, but basically what it means, this is more of a being aware of your underlying web technology issue than anything. And if you were to see a request, so the way this works is if you send a request and it has a parameter in it somewhere, so it can be in the URL request, so it can be in the actual URL as, let's say you do example.com / you see the question mark, a equals 123, that's a parameter value. So the parameter name is a, and the value is 123. You can also see it in cookies. You can also see it in a post body. So when you're making a request, you can pass these parameters. Basically, are variables that you can pass to a web application to do something different based on what that variable is. However, what you can do is if you send multiple parameters of the same name but different values, so if I say a equals 123 and a equals 456, what happens is different web technologies handle this differently. And if you're not anticipating how a web technology handles this, then it'll result in something happening in the application that you don't expect. And this can actually result in a security vulnerability given the right circumstances. And I'll show you some examples of exactly what that looks like. So remember how I mentioned there were different web technologies that handled it differently? Here's a really good starter grid that shows you all the different ways that these common technologies handle it. So if you take a look at ASP.NET, it actually concatenates them, all the values, with commas. And then it also, if you look at PHP, for example, it takes the last occurrence. So it'll ignore anything except for the last one that it sees. And then I believe Python, it makes it into an array. So there's all different ways that it's handled when you pass multiple values and multiple variables into an application with the same name. And if you're not anticipating this, then things can get ugly. So let's start with some exploits. The way this is commonly used is, one example is to actually leverage this confusion to bypass some kind of access control restriction, to bypass firewalls, web application firewalls, and specifically when you're using it for other attacks. Like if you're doing a SQL injection, if you were to pass this string, or pass this request to an application that's using ASP.NET, for example, this will actually result in this. Because remember, ASP.NET concatenates all values with commas. And if it's using Microsoft SQL in the backend, which is very likely because ASP.NET and Microsoft SQL are both Microsoft products and they're often used together, it will result in this query. And in Microsoft SQL, a comment actually adds a space as well. So this is a valid SQL command that does a select for name and password from the user's table. So this is a SQL injection hidden through HTTP parameter pollution. Now, this exact thing may not work anymore. I'm sure web application firewalls catch it now, but there's all different variations you can do because web application firewalls are typically signature-based rather than heuristics, or rather than, basically because they're signature-based, they can't catch everything. So if you find ways to modify this, you can probably get something like SQL injection. You can also do something like bypassing web application firewalls, like I mentioned before, but to get cross-site scripting. So if you take a look at this string, same concept as before, but this time we're passing in a script tag with an alert, which could obviously be more damaging if you do like steal a session token or something. But this is just a basic example to show how you can hide what the payload is through HTTP parameter pollution. So let's see what the next slide does. So that first one would basically give you a script tag. The second one is another way of bypassing input validation. Remember how I said there was 3 different places that you can actually pass parameters in the request? This shows, well, not only that you can pass it in 3 different spots, they are actually handled in a certain order. So if you know that order, you can pass variables in those different spots to get them to join together at the end. So here's an example. This request would result in, if you're using, again, ASP.NET, where it concatenates and adds commas, this would result in A equals 1, 2, 3, 4, 5, 6. So you can see that the first place it takes the value from, or the variables from, is the actual URL. So the URL variables takes first. Second, takes it from the post body. Let's see if I can get this thing. Here we go. The second one is the post body. Third one is the cookies. So if you can use them in that order and you actually understand the order that it's taken in, that's another way of bypassing input validation because you can join them together not just in one spot, but across different areas. So again, this is a tool that is not only a vulnerability in itself, but it's leveraged to bypass any kind of access control and get another vulnerability in, or exploit in, rather. Again, here's another way of hiding cross-site request forgery. Basically makes it look like a post action, but it's actually a delete action. I won't go into that any further. So here's an actual example of this being used in the wild. If you take, everyone here should be, or some people should be familiar with OAuth. OAuth is basically a way of authorizing an application to perform actions on your behalf. So with Twitter, if you use OAuth to authorize an application, that application can usually read from your timeline, write to your timeline, basically do everything on your behalf. You're basically giving them permission to use your account. So it's very dangerous when you have vulnerabilities in that kind of framework. However, in this case, the vulnerability wasn't in the framework, it was in the way that Twitter was handling the authorizations. So let me break this down here. This is an OAuth request to authorize periscope.tv to access your Twitter timeline. Because the host is Periscope TV, and digits is what Twitter at the time was using. I think they still do, but it's basically the domain to do OAuth. So what they do in this case is, it looks like Periscope.tv is getting access to your Twitter timeline and to use your Twitter account. However, what the attacker actually found, and this was on a bug bounty report, so you can see the report here, but what the attacker actually found was that if they passed a second host variable with attacker.com, Twitter passed Periscope.tv through, and it saw that that is a valid authorization that it will allow, or at least that this application will allow. However, by passing a second variable through with the host set to something different, in this case, attacker.com, it would actually authorize attacker.com, but look like it was authorizing periscope.tv. So someone who clicked this link would think that, okay, periscope.tv is going to be using my Twitter. That's fine. I use Periscope. I want it to easily post things to my Twitter timeline. However, what really happens is attacker.com gets your OAuth token, and they can then do everything on your account instead. So this is quickly patched, but this is a perfect example of HTTP parameter pollution used in the wild, which is really interesting. So I've showed you some ways that it can be exploited. I can show you what the vulnerability is. How do you actually test for it? So let's go through this. Really, the way to test for this is the best way is to just kind of test your applications as you use them. So for example, if you see a request with parameters in it in your application, try changing the values. Try passing a second parameter with the same name, different values, see what happens. See what you get on the other end. Remember that you can put it into those different spots in the request, so see what happens if you put it in either the URL request, the post body, or the cookies. You can actually automate this as well with Burp Suite Intruder. This is just another example, but you can pass in a second parameter with different name. Intruder just makes it really easy to automate stuff like this as well. So you can do it really quickly across all your application. So you want to look in the following sources. I think I get to another point later that I want to talk about. So here's some common sources that you're going to find. Parameters passed in, form fields, pagination. So that's like page equals 1, page equals 2, things like that. Admin page identifiers. So if you can access a page where the page is ID is 1, and that's the admin page. If you can only access it as admin, try accessing a regular page with, like, I don't know, ID of 1, 2, 3, 4, and then add another parameter value with page equals 1 and see if you can get to that second one or switch it around. So yeah, this is exactly what I'm talking about. And there's a way that you can actually intercept all post requests and parameters, but not just post requests. Now, Burp Suite makes it really easy because there's a setting to just intercept all requests that have parameters. So that could be get request, post request, doesn't matter. I mean, probably put requests, maybe, and other ones, but the most common ones are going to be get and post requests. So Burp Suite makes this super easy to actually do. So try one time when you're browsing through your application. Set this on, set up a Burp instance, set up the proxy, and then just enable this option. And make sure to set it the last option too, that it's in your scope, so you're only testing your own application. But try seeing what parameters you're seeing coming through, and try changing things as they go. So how do you actually defend against this? So let's take a look quickly through here. Really, the key thing is dynamic testing. So actually test your application to see how it handles this, because like I said, different application technologies handle parameters differently. So the only way to really know, as these technologies change and evolve and new ones get added, because I don't even think Node was on that list, try to understand, like test it in your environment to see how it handles it. Take a look through your source code. Find where parameters are accepted. Pretty easy. Validate how your WAF handles this, your web application firewall, because if it's handling things differently and passing things through to your application that you're not expecting, you may have tested your application thoroughly, but if you put something in front of it that's modifying those requests or stripping out parameters, if there's duplicate ones, whatever, you need to know how that reacts in your environment so you can adjust appropriately. And just general good practice, output encoding. So if someone does manage to get through your application's access control or get through any kind of defense against this just makes it so that the ensuing attack is neutered. So they can't get through with a cross-site scripting. They can't execute JavaScript if it's encoded properly. Again, there's ways around this, but this is just general good practice. And best case, be as explicit as possible. So strip duplicate parameters or explicitly choose the last one, whatever. It's up to you. If you're designing the application, be as explicit as possible. Always good practice. So here's some more further reading. Again, I'm going to post this afterwards, so you can check it out then. Overly permissive regular expressions. So I'm shorter on time, so I'm not going to go in depth here. But basically what this is regular expressions can be a source of vulnerabilities because they're often used for access control and input validation. So if you're trusting a regular expression that you wrote to catch everything, you're probably in for a world of hurt, because it won't. So when they're not tuned well, it can result in authorization bypasses. It can result in anomalies in your application that you didn't expect. So here's a comic, not really much to do with overly permissive regexes, but thought you'd enjoy it. Everyone likes XKCD. So let's move on to some common gotchas. Again, I'll run through this pretty quickly. Make sure that you caught the right character case when you're using regular expressions, because it's by default is case sensitive. So check that. You can also use /i as a modifier to make it insensitive. Word boundaries. Basically, when you're looking at a word, you want to only accept to the point where you're looking for. So you don't want to accept in your application admin and administrative assistant. Probably aren't the same role. So use word boundaries to delineate them, which is usually /b. Do you really need to use a star? So this is the wildcard that basically accepts 0 or any. If you're using an or condition, especially, this is dangerous because if it's in the first condition, it will usually match almost anything and then always allow someone through. So here's an example. This is a or condition where the first match is always going to be true because it's either 0 digits or any number of digits or really, so it'll match any of these things, okay? So just be aware when you're going to be using the star character. Special characters, if you actually need to use special characters in your regular expressions, use a / to negate them. And don't try to parse HTML with regular expressions. It's painful and it sucks as a developer because it's always changing and there's just so many edge cases. Just ask Cloudflare. Just because if you're trying to do this to parse things, you're probably going to miss something. There's a lot of really good libraries for this, so don't try to do it on your own. Just don't. Exploits. So let's look at some regular expression exploits. So this was a case where so you can actually see this is I think it was a bug bounty. White space and multi-line abuse to remote code execution. So they actually got remote code execution due to this flaw. So if you take a look at this regular expression, it's supposed to match for anything, basically anything .rpt. But the flaw here, so it'll look something like this will match. The flaw here is that because it's got this character here, there's two flaws. First off, it's got the /s character. /s not only includes spaces, but it's also tabs, line breaks, and form feeds. Line breaks can be used in malicious ways when it's passed into a command. So look at this. If you pass this line break right here with the %0a, the next command executed will be cat etc password, which is not good on a Linux system. And then this. So this would actually match because it actually hits the anything matches .rpt. However, because of this multi-line modifier here, the way that PHP handles multi-line is that it not only checks on multiple lines, but it will look until it'll accept and take anything, like the whole line rather than the whole string that matches, and puts it into your output. So something like this would also work because it takes this matches, but it continues for the rest of the line because of the multi-line modifier. So this will be completely valid. It'll pass this into the command in the back end. It accepts the file, but then it also executes this, this actual command to output your password file in Linux. Not good. Oh, and interesting thing about this vulnerability is actually the default on Ruby on Rails for a while. So by default, it was doing multi-line, so you could actually pass something like this into almost anything that was taking a regular expression, and if it was passing it back to a back-end command, then it would execute a script or reflect it back. Or you could basically enter anything as long as you use the line breaks, and then it would execute that command. So as long as it was found somewhere in there, some kind of valid match, you could continue it with the line break, and it would also use that. So it's pretty interesting. So this left a bunch of websites exposed at the time that were using Ruby on Rails. I think it was like WordPress, Tumblr, GitHub, a bunch of them. Next one, blacklist bypass. So this is pretty simple. Essentially, they were doing a blacklist that this came out to this, but if you tried to do /title, it was caught by the blacklist. So for those of you that aren't familiar, there's two concepts. One is a blacklist, one is a whitelist. Blacklist matches on things that you specify. Whitelist basically says, blacklist is usually used to say don't allow these specific things that you specify. Whitelist is usually used in reverse, where it says only allow these things that you specify, which means it catches a lot more things in it. So in this case, they were doing a blacklist, so they were specifically looking for the /title in the input, so you couldn't then continue on and pass in HTML or JavaScript. And all you had to do really to bypass this was something like this, where you would pass in extra, this looks kind of convoluted because of all the URL encoding, but basically what it is it would result in this. So by passing in not just the /title, you can also pass in an ID and then a bunch of other things it doesn't expect that are valid HTML. Because it wasn't checking for them in the regular expression, in the blacklist for the regular expression, it got through and then you got code execution, or cross-site scripting rather. So how do you actually test for this? Really, the thing that comes to testing, I'll kind of sum it up right now. It's most effective with doing white box testing, because if you're looking at regular expressions, they're hard to parse if you don't see them. So you can try fuzzing things, but really the most effective way is to look in the source code. So you can use any of these tools to check your regular expressions. They're really, really good. Any of these, doesn't matter. It's just kind of a sanity check. Dynamically test them with some fuzzy input. So fuzzing is the practice of sending in particularly incorrect input to see what happens and see how it reacts. There's a really good list here. If you look at sec lists, they have a whole section on fuzzing. I would highly recommend checking this out, by the way, because they have a whole bunch of polyglots, basically a bunch of strings that you can use in your testing for cross-site scripting, SQL injection, things like this. So test with those in your applications, see what happens. And then try passing in line breaks as well. So how do you defend against this? Really, all of these solutions are just kind of around best programming practices with testing sprinkled in. So keep it simple, perform transformations in stages. Again, I'm going to rush through this a little bit. Test a lot, and always try to have like a set of fresh eyes on it because it gets really tiring looking at regular expressions for a long period of time. I know I worked on an application that was solely regular expressions before, taking data, passing data, interpreting data. It was a pain. So get another set of eyes to look at it, and it really helps because sometimes you just get lost in the forest. And use proven regular expressions. So here's one that'll help you out. This is this finds an IPv4 address. So it's just really best practices around using regular expressions is be modular, test it as much as you can, and have someone else look at it. And again, use best practices whenever possible, which is something like these. Oh, and really good practice everywhere, whitelist, not blacklist. Here's some sources and further reading if you want to learn more about regular expressions. There's actually a lot to it, and I'm sure if you're doing bug bounty hunting, if you are a security researcher, if you're a developer, there's a lot to be found in regular expressions because a lot of people don't understand them and a lot of people don't want to understand them. So if you get good at this, I'm sure there's a lot of things that you can find. So here's some good, useful sources. Last but not least, server-side request forgery. So SSRF, because I'm not going to say the 4 words the whole time, SSRF is basically when an attacker can force a server to perform a request on their behalf. So instead of, if I were to send a request normally to a location and it's blocked, I can pass it through another server. It basically makes a server act on your behalf, which is kind of cool if it has this vulnerability. Cool for the attacker, bad for the defender, but that's always the case, isn't it? So how is SRF actually used? Often it's used to bypass firewalls. So when you can force an application to make essentially the application becomes your proxy. When you can force an application to make a request on your behalf, if there's a firewall blocking your IP, or any IP except for that server, because it's a trusted server, then you can then bypass those firewalls. It's pretty easy. But not only that, it gets more dangerous when that server has the internal network interface exposed. So most web servers, or really any server that are exposed to the internet, a lot of them have some kind of way back into the internal network. You probably don't need that, but if they have some kind of way inside the internal network, then you can then reach a network and computers that aren't accessible from anywhere on the internet because of this vulnerability. So it opens up a lot of vulnerability, a lot of further exposure to your internal environment. And it's really cool because this allows, when you find an SSRF vulnerability, because of the nature of it, it turns an application attack into a network attack. So it allows you to essentially turn that host into a port scanning bot or a bot on your behalf. And because of that, it's useful for enumeration reconnaissance. So you can then perform a whole bunch of scans out on the internet, on the internal network, without your IP being exposed. And I think that's the next point. Yes. So because the destination actually sees only the server's address, not your own, attackers love this because then this is another way of them hiding their own source address. So it's really handy to attackers. And this is how it's often introduced. So SOP stands for Same Origin Policy. It's a browser defense that is present in really all major browsers that prevents Site A, for example, from reaching out, making a request to Site B, and getting content back. Unless you have something set up, which I will talk about later, to actually do this properly. Developers find this bothersome because sometimes they want to go out to Site B and get content and return it back. So one way that they will get around this is by essentially turning their server into a HTTP client for them to make the request behind the scenes, and then return it back to the user in the front end. And I'll show you how this can get dangerous later. Actually, I'll tell you right now. It actually can be leveraged to get cross-site scripting by the return content. So what that means is if an attacker can force a server to make a request to their own server and then return that content back, if that content is their own HTML that they've designed and scripted, including JavaScript, then they just got control of your browser because of that return content. So it's a way of chaining, it's a way of using this to get another vulnerability or another exploit as well, which is kind of cool. So let's look at some exploits. So this one's really interesting, and for all of you that are running on AWS, pay particular attention because you will probably learn something that you may not have known. Or you may know it and it was just novel to me. So attack steps. What happened was the attacker found this URL. Funny enough, if you ever see URL equals in the browser or in the URL, try passing in other URLs and see what comes back, because that can be an open redirect as well. But anyways, they found this, and they found that it only loads images. So you can see it's a media preview function, so that kind of makes sense. But it will only return back images based on whatever URL you pass into that parameter. However, if you just pass in, it's just looking for .png or another extension like that, which kind of relates back to the last vulnerability we talked about, where it was doing a regular expression for a specific instance and not checking other things like content type. So in this case, it was just looking for .png or something like that, and by passing in this parameter, .png, it does nothing. You can just return back. This was the attacker's website, zayat.org, and I left it in there just to kind of, it was their attack, so I left it. Anyways, so they can return back their entire website just from this, not even in an iframe. It returns back the whole website, which gives you a lot of power, because then you can do something like this and return back your own cross-site scripting payload that you want. So this is what they did. But not only that, they didn't stop here. And hey, look, an overly permissive regular expression. They didn't stop here. After that, they realized that because it was hosted on AWS, there's a particular endpoint that if you can reach that endpoint from a trusted source, gives you a lot of information. Bonus points if you already have that in your head and you know exactly what I'm about to say. So did you know if you query this IP from an AWS instance, it will give you back, it basically has a REST API, where you can query a ton of information about the server, because it's only accessible from that server itself. It's only a local one. It's only internal behind it. But because he, as the attacker, was able to make that server make any request on his behalf, including to that internal address, he was able to access this. So for example, they did this, and they got pretty much everything. So some of the metadata is, here I'm going to iterate through some of them. AMI ID, reservation ID, local host name, public keys, OpenSSH keys, security credentials by role, security groups, user data, and on and on and on. There's a lot in there, and they basically found all of it. So here's a guide that you're going to want to note down if you're running AWS. This is some of the functions that you can actually call from that endpoint. It's helpful. It's really valuable if you want to script out some kind of information about, especially if you're in like a DevOps workspace where you need to get more information about the endpoint or the instance itself. This is going to be really handy for you. Let's move on. Google digs Google. Google actually had a toolbox where they allowed you to do a whole bunch of stuff that you can just do on your client anyways, but do it with Google, because it's Google Apps. So they had this spot where it was you could use a tool called Digg. Digg is a command that's usually built with most Linux distros. Does Windows have it? I don't know. I don't use Windows as much. So Digg basically allows you to make a request or use the tool to check a particular domain with the name server that you provide, and it will return back the DNS information for that name server, or sorry, for that actual domain. So they gave you a web interface to do this, because why not? Google Apps. And it returns back the information. The interesting thing, though, is if you modify the request and change that name server to 127.0.0.1, that's the local host. And Google happened to be running a DNS server on that web application. So what they did was the attacker could then just keep making a bunch of requests to this Google app. And then with that internal name server specified, they enumerated pretty much all of Google's internal namespace. They could see every single instance, every domain, every host name inside of Google. And fun fact about this, Google was actually running a Minecraft server inside their internal network. Big surprise. So how do you actually test for server-side request forgery? First off, if you actually see a URL provided in a request, try changing it. And again, you can script this out as well with Burp. Change it to a few of the following things. One, try google.com or another remote URL, see if it loads that, or your own domain, see if it loads that. Another one is the loopback address, like they did in that, on that last example with Google. Try seeing what else is running on that local server, because if you can make requests on that server, it's very likely that there's other services running on that server, because most people don't have the money to do a dedicated instance for every single service they're running. So it's very possible that you're going to find something else on that local server. Try local IPs, see if you can get behind the server to the local address, or to the local address space. try a different protocol. This is interesting. I will come back to this in a little bit, but basically, when you're in your browser, if you look at the URL, most of them start with HTTP or HTTPS. But you can actually make requests with other URL forms, such as like file, SSH, FTP. File in particular will return back a local file, the contents of a local file in your browser. So this can be particularly dangerous if you as an attacker, or an attacker can actually use your server to query the local files there. You can imagine there's probably some files that you don't want them to see. Same with SSH and FTP. There's a lot there. Just the different protocol URLs is something that a lot of mobile applications use as well. So you'll see like custom URL schemes for like for Spotify, for Twitter, a number of other ones where it'll be like I don't know, Spotify : / something, and it'll call out their mobile applications. There may be other things you can do there if you can find like a mobile app server. Just thinking out loud. Try a different port. Similarly to if there's other services running on the same box, if you try a different port, you can basically enumerate every service that's running on that, or if you find another domain or another IP that's reachable from that server, then you can then find maybe there's other services other than just web services running. So you can enumerate. It basically turns this server into Nmap for you, but a much more dumbed down version of Nmap. And like I said, burp, sweet, intruder makes this really, really easy. If you sort by response sizes, it'll be a lot easier to kind of catch which things are positive hits for you. Continued, I'm not going to dive into this, it's going to take too long, but if you have XML external entities, like this exploit, then basically it'll allow, if you can make a request out to an external URL that's also server-side across forgery, you can check this one out for more information on that after. It's just a way of using multiple exploits together. Oh, yes, this is a key point here. So if you don't have your own server set up that you're just having there just to listen for requests for this vulnerability, you can use Burp's collaborator servers as well, because they will just provide you free servers that will monitor for requests to them with unique information, and then it will return back in your Burp instance anytime it hears back from it. Even if it's like way down the line, let's say if like if you get a vulnerability where it's making a request out and it comes back in the logs or something, you can still get an alert then. So Burp's collaborator servers are really useful. I don't work for Burp Suite, I promise. They just make really good tools. So how do you actually defend against server-side request forgery? So I mentioned same origin policy. Remember that it exists for a reason. Don't try to use JSONP or a server-side workaround. So the server-side workaround is basically what I just described about making a request with your server, returning the content back to the client from there. However, you can use something called JSONP, which is, I think, JSON with padding? I can't remember. Anyways, JSONP, what it does is basically it exploits a situation in your browser where your browser can make a request to another domain for a JavaScript file. Maybe not for other resources, but for JavaScript files, they're allowed. And so what this other server will do is if you call a JavaScript file at with a particular, like you pass in like a specific location, it will return back a specific function for you. So it's a way of calling a function, a dynamic function on another server, and returning it back to you in a more roundabout way. Don't do it. Just like if you can avoid it, it will lead to things like server-side request forgery. Instead, use cross-origin request sharing, CORS. This was made just for this reason. So if you are able to control server domain a.com and b.com, then you can set up a CORS rule which will allow, from b.com, you will allow a.com to make a request for JavaScript, CSS, whatever. So you can actually use CORS to legitimately request resources from another domain and bring it back in the client. So use that. And whitelist allowed domains and protocols. Whitelist over blacklist is important. I'm going to show you why in the next set of slides. In particular in PHP, this is important. But when you're looking at domains and protocols, remember how I said you can use more than just HTTP? When you're thinking about what you're whitelisting, also think about what kind of protocols you're whitelisting. If you only need to make a request to HTTP, which is likely, or HTTPS, try whitelisting that as well, specifically. And to prevent, either don't have an internal interface on your server, your web server, or whatever server is exposed to the internet, or have some kind of firewall rules severely limiting what can access from the server to the internal network, so that if an attacker does get an SSRF exploit, they then cannot enumerate and access your entire internal network, which would otherwise be safely hidden from the dangerous internet. And so I mentioned whitelisting protocols. You get an idea why, but in practice, you may think, oh, you can't do this with most technologies. Well, that's not true because we have PHP. So PHP actually supports the following protocol URLs by default. There's a lot. You can find more information there. So if you're using PHP, be especially careful with protocol URLs that are being used behind the scenes. And here's some more further reading for you. I did a blog post on, I was doing a bunch of open source security reviews recently and found one where it was basically a design level SSRF vulnerability. So if you check this out, I did a whole write-up on it. This will give you more information. So let's review. OWASP Top 10, 2013. I'm not going to read this out to you. You can read. Here's the top 5. There's the next 5. Looking beyond the OWASP Top 10, we have HTTP parameter pollution. Remember, if you pass multiple parameters with the same name, different values, see what happens. It could result in anomalies because different web application servers and technologies handle it differently. Overly permissive regular expression, check your regexes, because if you're using it for access control or input validation, which is very likely, you got to make sure that it's tuned properly. Otherwise, it can allow for easy bypasses. And server-side request forgery. Be sure when you're making requests on behalf of users that you whitelist as much as possible and really try not to allow access to the internal network because server-side request forgery basically allows an attacker to make a request anywhere they want through your vulnerable machine. So there's actually a release candidate for OWASP Top 10 2017 because the last one was 2013. There's a few changes made to it. Right now it's still in public comment, so it's not firm. But that should be available in roughly July or August because public comments are closed at the end of June, so soon. And here's what the changes are. Basically, they added a A4 broken access control, which combines insecure direct object references and mixed function level access control. So it's A4 now means broken access control. Attackers can bypass authentication and authorization controls. A7 is insufficient attack protection. This one's got a lot of press, negative press really, because people thought that it shouldn't really fall into it, and it's kind of a catch-all. Basically, what A7 insufficient attack protection is saying is that developers should incorporate automatic detection, logging, responding, and even blocking exploit attempts. I don't know if this is necessarily a vulnerability, so I'm going to leave it up to you to decide whether this should be in there. Add your comments, whatever. Look it up online. There's a lot of commentary on it. That's A7. And the last one, A10, underprotected APIs, basically means that protect your APIs, which is weird because all the other OWASP Top 10 in the past has really applied to APIs just as well as web applications. So I don't understand where they were going with this. But moral of the story, all of these vulnerabilities that I talked about still apply, even to the new version of the OWASP Top 10. So final message that I'm going to leave you with is this. The OWASP Top 10 really is a good start for developers, for someone new to security, web application security, if they want to learn more. But there is so much more than just the OWASP Top 10. And it's really, really important that as a security professional, as an advocate for this, you should always be learning because there is constantly going to be new things coming out. There could easily be another 5 vulnerability types that I talk about. So moral of the story, understand that it's a good start, but you should always be learning more. And I think this is why we're all here. We're all here because we want to learn more about security. Keep that up, because that is what drives the security industry. That's what makes us good at protecting our applications. So you should always be trying to learn more. And to help you out with that, I've provided a few resources that you can use to keep learning. These are just some things I found recently that I use more often to actually keep up to date on security vulnerabilities and exploits. One is the Hacktivity feed. So it's a bug bounty platform. They basically publish a lot of bug bounty reports. Twitter is a really good place to, this is where I get most of my news, to be completely honest. If you're following the right people, you can usually catch security issues and vulnerabilities and exploits before anyone else does. The problem with that is you have to kind of curate who you're following to get that information. So my advice to you would be to look at who is speaking at this conference, speaking at other conferences, follow them, see what they follow, see who they like, see who they retweet, and eventually you'll just start to build up your where you get the information from. Reddit, I don't really use this all that often, but it's especially beginner friendly. So if you're looking for network security, especially kind of content, check that out. And HackerOne, again, they have a 0 daily newsletter, which just recently came out, and I found it's actually pretty useful. So the point here really is that if it's a good start, but there's so much more. And if you need help understanding where to start from or where to continue, or you need other resources, or you have any questions around the things that I've talked about, please feel free to reach out. I'm always open. I'm pretty happy to help. And if I can't help you, then I can always point you to the right person that can. So I think we're all in this together. We're all trying to learn more, and we want to advance the security industry by learning more and understanding that there is so much out there that we still need to know. So with that, I want to say thank you very much, and I appreciate you coming out.